See, I watch them. Look at yourself.
Okay, so let's continue. Let's continue. I'm giving you the question. Are you ready? Yes, you have to be ready. Two forces acting in opposite directions. Two forces acting in opposite directions have a resultant of 10 Newton. Can I continue?
No, please.
Two forces acting in opposite directions have a resultant of 10 Newton. If they act at right angles to each other, the resultant is 50 Newton. If they act at right angles to each other, the resultant is 50 Newton. Find the magnitude of the forces. This is the problem of the day. I want you to think through. Okay, picture it. Nanama.
Sir, please, we do not get the question well.
I'll give you the question well. So two forces acting in opposite directions have a resultant of 10 Newton. Nanama. So two forces acting in opposite directions have a resultant of 10 Newton. If they act at right angles to each other, the resultant is 50 Newton. Find the magnitude of the forces. Justine.
Sir, please, can you read the question again?
All right, so we have two forces. Yes, two forces acting in opposite directions have a resultant of 10 Newton. So when they are acting in opposite directions, they have a resultant of 10 Newton. Okay. If they act at right angle to each other, they have a resultant of 50 Newton. They have a resultant of 50 Newton if they act at right angles to each other. Now the question is that find the resultant, the magnitude of the two forces. So, yes, if you are not getting it, so please, it will be posted on the platform soon. Okay. So let's see how it will be sent to the platform soon, and it is there. Please pick it from the platform. Okay. All right. So let's go through the question. How do we solve this challenge? We have two questions. Forces. When they are acting oppositely, they have a resultant of 10 Newton. When they are acting at right angle to each other, they have a resultant of 50. But let's first draw. This is the point where the two forces act. So it's like you and I place at both ends of the table being asked to push. So you push and I push. And so what are we doing? We are exerting the force on the table. So the table is the point where the two forces exert. Are we fine?
No, please.
So this is the common point. It can even be a body. A body, a mass, whatever. So a force, one of the forces is in this direction. Another force is in the opposite direction. This is like one of you has to stand here, one of you has to stand at the other end and being asked to push the table. So you push, the other person also does what? Pushes. Okay, so when you have this situation, what will happen? What will be the resultant? Okay, when you have this situation, what will be the result? But we've been given the result. Okay, so the forces are F1 and then F2. Now, practically, let's be practical. If I ask one of you to push an object and I also push the object in the opposite direction, okay, in the opposite direction, the object, the person that applies the larger force would overcome the person that applies the lesser force. So if we are pushing a table, the table would move in the direction of the one that is pushing harder or with a larger force. Please, are you with me?
Yes, please.
Oh, so
Yes.
in effect, the larger force would overcome the smaller force, and that will be shown by the motion or movement of the mass or of the table. So when two forces act on a body in this manner, if F2 is greater than F1, then the resultant force will be subtracting F1 from F2. The resultant is F2 minus F1. And that is if this is the condition, if F2 is greater than F1. So in our consideration, we are assuming that F2 is greater than F1. Are we okay?
Yes.
Go. So
Yes.
the question says that if the two forces act in opposite directions, they have a resultant of 10. So it means F2 minus F1 is equal to a resultant of 10 Newton. And this becomes equation 1. Let's look at the second situation. If they act at right angles to each other, the resultant is 50 Newton. So now the same two forces are acting perpendicularly. So F2, F1, the angle between them must be 90. Okay, and as we discussed before, if you have this situation, the resultant would always act along the diagonal. And we use equal vectors to bring F2 to this side. So this is F2, this is perpendicular. This side therefore becomes the resultant force. Are we fine? Are we okay?
Yes.
No, please.
Okay, so The two in the second scenario, the relationship between the two forces is such that they are perpendicularly to one another. Are we okay? Okay, so this is F2, this is F1, and the angle between them is 90 degrees. Okay, as we discussed earlier, when you have this situation, the resultant always acts along the diagonal, and you get to understand better when we start vectors. Okay, so from this, we can deduce, apply Pythagoras theorem to this, and that is the square of the resultant must be equal to, yes, the square of the resultant must be equal to, yes, help me.
F2 plus F1.
No, I won't
The
buy
square of F1 plus the square of
The square
F2.
of F1 plus the square of F2.
exactly Pythagoras theorem. Pythagoras theorem. Okay. So
Okay.
F1 squared plus F2 squared becomes the result. And the question said that in this particular situation, the resultant is 50. So we have 50 squared is equal to F1 squared plus F2 squared. And this is equation 2. Justin, your hand is up.
Sir, please, I can't see what's on the board.
Really?
Yes, please, I can't see it.
Okay.
It's black.
It's blurry.
So I
Yeah.
can't see that all.
Hmm.
Me too, I can't see.
Can't see at all.
Okay, let's
Me too, I can't see.
can you rejoin?
Please, me too, I cannot see.
Rejoin and let's see if that will fix the problem for us. Rejoin. Okay.
Okay.
But is it a general problem to all of you
Yes,
Yes.
please.
that you can see?
Yes, please. Yes, please.
But I can
Yes,
see.
please.
I can. All right. So let me restart so you can rejoin. Okay.
This is, yeah,
Hello.
it's like a light is reflecting on the board. So
I
you
get
can't-
you. I get
It's
you.
like you open your window.
I get you. Let me reposition. Okay, first let me restart. Okay. Let me restart. I think that would